Okay, I usually don't record homework problems on video, but I felt that the dynamics of this one justified doing a recording. This is uh, the Physics for Scientists and Engineers by Serway and Jewett edition, the 10th edition, chapter 17, problem 10. So let me read the problem statement. A standing wave is described by the wave function y equals 6 sine of pi over 2x times the cosine of 100 pi t, where x and y are in meters and t is in seconds. The first part of this is prepare a graph showing y as a function of x for 5 instances. T equals 0, 5 milliseconds, 10 milliseconds, 15 milliseconds, and 20 milliseconds. So, not wanting to plot it by hand, I pulled out Mathematica and put the little plot. And you can see it's the same 6 sine pi over 2 times x times cosine 100 pi. And in the first case, it's t equals 0. So there's the 0. And I just let it go from x from -4 to 4. And I gave it that particular plot range. The reason I did the plot range is you'll see in the next example. And this is the plot that you get. And I did it for 5 milliseconds, 0.0005 seconds, and it looks the same. However, it's not the same. If you look, it goes from 5 times 10 to the minus 16, 4 times 10 to the minus 16 to minus 4 times 10 to the minus 16. So it's much more reduced. And if I adjust the plot range to where it shows that, that's why I did all of these without the plot range, and they all look similar. Now, if we plot that, you'll see, oh, it's greatly diminished from the previous one. It doesn't look like it. And so here it is for t equals 0 seconds, for 5 milliseconds, for 10 seconds, and you can see it's the 180 degrees out from the 0 milliseconds. This is it for 15, and this is it for 20. And I felt that this didn't really show the dynamics of this equation, so I decided to do a little manipulate so that you can see what's actually happening. And so here we are at 0, and as we go from 0 to 5 to 10, there's about 10, there's 15, and there's 20. So let's just play it. Let's play it in slow motion so you can see it. So the yes, we have an oscillatory wave, but even if you were to pick one point, not at the 0 crossings, the 0 crossings remain 0, but if you were to pick any point, let's say on this first peak, it oscillates back and forth in simple harmonic motion, going here it's at what is it, -6, and it's going to go up to +6. Ordinarily, sine and cosine only go from -1 to 1, but if you see, we have a factor here of 6. So that's how we're getting the 6. But these points, these peak points, and any point that's not on the 0 crossing is actually experiencing simple harmonic motion. So I just wanted to show you the dynamics of this particular equation. Just the static displays seen here don't really show you what's happening as it transitions from 0 to 20 milliseconds. Okay, that's all I wanted to show.